Hello ladies and gentlemen, in this video we will learn how to create a graph. Okay, so I'm going to go through each and every single requirement, and by the end I will have a quick recap so that you can put in your notes all the necessary steps to create a graph for my class. The first thing you should always have is a title. The format of the title is dependent variable versus independent variable. If you don't know what an independent or dependent variable is, write down these definitions. An independent variable is a variable that is varied or manipulated by the researcher, the effect that is considered to be the cause. Okay, so independent variable is what is doing the changing. Dependent variable is a variable that is the response that is measured. It's like the effect due to the independent variable. Okay, so I italicized, bolded, and underlined the words cause and effect. So if you ever get confused, think in your head, what is causing the effect? From here on out, independent variable will be written as IV. Okay, independent variable is the antecedent, meaning that it comes first, and the dependent variable is the consequent. It's what comes after. Okay, so something needs to happen first in order for a effect or a result to happen, a consequence. So simply put, a independent variable influences change in the dependent variable. A couple of examples. In this scenario, I'm asking you, what is the effect of time spent studying on the score of your exams? Okay, so obviously, the more time you study for an exam, the better your score is. But if we were to identify the independent variable and the dependent variable, it will go something like this. Independent variable is the time spent studying, and dependent variable is the score on exams. Okay, so for the title of our graph, we would write score versus time. Think about it this way. If it ever confuses you between independent variable and dependent variable, if you were to swap it around, okay, and say it in a sentence, does that sentence make sense? The score on your exams changes the time you spend studying for that exam. That makes no sense. Why study for that test that you already got a score on, or not even that, but your score alters time? That's a little weird. Here's another example. Does temperature affect how fast an ice cube melts? Alright. You can pause the video right now and try to identify the independent variable and dependent variable if you want. The independent variable is the temperature. The dependent variable is the rate of melting, okay, how fast it melts. So, for a title, we would write dependent variable first, and then independent variable, the rate of melting versus the temperature. Now, once again, do our test, flip it around, does it make sense? If the ice cube melts faster, then the temperature will change. See, that doesn't make sense, okay? The temperature will change regardless of the ice cube melting or if it stays frozen. Okay, here's another requirement for your graphs. The title will always be in dependent variable versus independent variable form, aka your y-axis versus your x-axis. Always label the axis with the correct units. Here's an example of how we can label an axis. Okay, the y label, score on exam, would be percent. Okay, the unit would be the percent. For the x label, time spent studying, the unit that I chose for this is minutes. Now when you put it on your graph, you don't have to write out minutes. You can do an abbreviated form if you would like. Alright, so here we have score versus time. Okay, notice how up here we wrote the title correctly, score versus time. Score, of course, being the y-axis, okay, percent, and time being the x-axis, minutes. Alright, so if we were to graph something like this, we would see that the more time that we spend studying, the higher the score, if you could follow my mouse. Second example, does temperature affect how fast an ice cube melts? Independent variable will be temperature, dependent variable would be rate of melting. We will label the y label, or the y-axis, rate of melting, and it would be in milliliters. And the x-axis label would be temperature in degrees Celsius. And if we were to create a graph, it would look something like this. The y-axis will be rate of melting in milliliters, and the x-axis will be temperature in Celsius. Notice here I didn't write out the word Celsius, but I just put the unit there. Okay, and if we think about this, this also makes sense. The higher the temperature, the faster it would melt. Okay, or the amount that it would melt. Next step, after you create a title and after you create the axis title with the proper unit label, you have to choose a scale. Right? Choose a scale for both axes so that the graph spans as much as possible. If you're drawing a graph by hand, try to take up as much space as possible. Okay? Don't try to save space. It's easier for you and for me as a teacher to see the trends in the data. Choose scales for the x and y axis that are easy to read and plot. Alright. Here's an important note. Your y-axis and your x-axis scale do not have to equal. For example, if your x-axis goes by tens, your y-axis can go by ones, fives, 20s, 100s. Right? They do not have to be the same. After you create a scale, you plot your data. Okay? Now notice how I said just plot your data, because you do not connect the data points ever. Alright? I'm going to go back a slide. This is what we call a scatter plot. Alright? In a scatter plot, the line does not go from point to point. What you do need to do is create a line of best fit. That is this blue line here, and it's basically a line that shows the general direction that a group of points seem to be heading. So if we take a look at these yellow points, they seem to be heading in the upper right direction, lower right to upper right. And so we would create a line that would span all the way across. Okay. Oops. After that, you have to write an equation for the line of best fit. Okay. In order to find slope, or the label for slope is m, it's rise over run. Pick 2 points. The y point for point 2 minus the y point for point 1 over x2 minus x1 gives you the slope. And then you see where the line of best fit crosses the y-axis, and that will be your b, as seen here in the slope-intercept form. Okay, so we can see that m is slope. The equation is right here, rise over run, and b is your y-intercept. And all you have to do is plug in the numbers that you found. Alright, so to finish this video, let's have a quick recap. Create a title in y versus x form, label and place units on the appropriate axes, plot the data, create a line of best fit, and then write an equation in slope-intercept form next to the line of best fit. Thank you.